this video, we're going to apply the composition of functions to determine if functions are inverses of each other. So we want to know if these two functions, the function f and the function g, if they are inverses of each other. So the way that we can determine this is by doing composition of functions. So if the function f of g of x and g of f of x both simplify to x, then they are inverses of each other. So you have to test both conditions. You can't just do one, and if that simplifies to x, and you're good. You have to do both. So that's what we're going to do. So I'm going to look at my function. I'm going to write it in black. F of g of x alongside the function g of f of x. Okay, so these are just going to give me expressions, and I'm going to see what happens when I do the math. So let's rewrite this. Remember in a previous video I said I'd like to rewrite this to be f of g of x. And this one is g of f of x. Okay? So in this form it's a little easier for us to see. We have a variable, no number, which means I'm going to start with the outside, my function f. So my function f is 3x minus 2. But remember, there's a placeholder there. So I'm going to write my function of x, f, as 3x minus 2. So what's my g function? My g function is what's going inside here, because that's what's inside the parentheses here. My g function is this fraction, x plus 2 divided by 3. So it's as simple as that. So now we have to do the math. So what we have here, I'm going to rewrite this so we can see it a little clearer. This is 3 times x plus 2 divided by 3 minus 2. This is 3 times this whole thing. Well, this is the same as 3 over 1 times some number over 3. 3 divided by 3 is 1, so that leaves me with x plus 2 minus 2, and 2 minus 2 is 0, so that leaves me with x. So my f of g function simplified to x. But I can't stop there. I have to do the other side. So let's do the other side. My main function here is g. So what is g? G is x plus 2 over 3. So notice I left this as a placeholder because f of x is going to go into whatever x used to be. So f of x was 3x minus 2. So we can see here we got to do the numerator first. This is the same as 3x minus 2 plus 2 over 3. This here, negative 2 plus 2 becomes 0. So I'm left with 3x over 3. 3 divided by 3 is 1. So I'm left with x. So we can see that my g of x function also simplified to x. So that means these are inverses of each other. So now that I've showed you how to figure it out, algebraically, I'm going to show you again on the graph. So we are going to plot our f function. So our f function, f at x, was 3x minus 2. So this is a linear function. It should be fairly easy to graph. We're going to start at our y-intercept, and our y-intercept is negative 2, which is right here. We have a slope of 3, which means we're going to go up 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And so forth. So we're going to keep that going. On the other function, I'm going to use a calculator just because it'd be kind of hard to graph our function given that our y-intercept is 2/3. So for our g function, our g of x is x plus 2 over 3. So this here, 2/3, is our y-intercept, which is going to be kind of tricky to plot. So I'd rather just get some points. So we're going to use a calculator. I've already put in both functions into the calculator. I'm only going to look at the one that I'm interested in graphing. Notice I grouped my numerator. My numerator is one number, so I grouped it. There's another way you can do this in your calculator, but I don't want to get into that right now. So when I look at my graph, I can see it's fairly flat, and it has a positive slope. And then I look at my table, I'm only going to plot the integers that I can put down. You can see we have a lot of decimals there. So let's get to something kind of nice. So at -5, I have -1. At -2, I have 0. At 1, I have 1, and we can see they're intersect right there. At 4, I have 2. Okay, so we can see our slope is in fact 1/3. So I can just continue up 1, 1, 2, 3 to the right, up 1, 1, 2, 3 to the right, and then I can do the other direction, down 1, 1, 2, 3 to the left. Okay, so this is my g function. I usually use a ruler, but I have misplaced my ruler, so I'm drawing the best I can by hand. So this here is my g of x, and this here is my f of x. So we notice they reflect over each other, and if you remember, I said they reflect over the line y equals x. So let's draw in our line y equals x. Well, y equals x goes right at 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 0, 0, -1, -1, and so forth. So if you look, if you were to fold your graph over this line, you would in fact see that this would lay on this and this would lay on top of that. They lay on each other. So it's a reflection over the line y equals x. And then again, the other way that you could check this out is to look at the table to see if your x and your y values have switched. But this video is already at 9 minutes, so I'm just going to stop there.